Okay guys, so I'm going to explain how to determine the heat of combustion of an organic compound in kilojoules per mole. Okay, so the first thing that we need to do is we need to balance the equation. Okay, our equation here, we are combusting ethanol, which is so the molecular formula for ethanol is C2H6O. Okay, we have 1, 2, 3, 4, 5, 6 hydrogens, 2 carbons, and 1 O. Okay, so if we add that to oxygen, then we form carbon dioxide and water. Okay, so we have 3, 2, and 3. Now this equation is balanced. The second step that we need to do is we need to use the equation Q equal mc delta T. And keep in mind that this is Q for water, not for ethanol. Okay, if we want to then relate this to that of ethanol, we'll have Q of water equal minus Q of ethanol combustion. And this is because the heat that is absorbed by the water was released by the ethanol combustion. That's why they're equal but opposite. Of course, this is not a perfect process. This is why we never get the true value. We always get less than that because there's a lot of heat lost to the surrounding. Okay, so now third point, for Q of water equals the mass of water. In this case, mass of water is 100 grams. And then delta T of water will be the difference between 360 and 295. So M is 100 times the specific heat capacity for water is 4.18 multiplied by the delta T, which is 65. So the units that you get will be in joules. And to get this in kilojoules, you have to divide by 1,000. So this will be 27.17 kilojoules. Okay. Now we've done the first part here because the question says we should report our heat of combustion in kilojoules per mole. We have done the kilojoules part. We have not done the per mole part. For the per mole part, we need to know how much ethanol was used to produce this much heat. So to do that, we need to figure out the moles of ethanol. We use our popular equation here. Moles equal mass over molar mass. The mass is 28.50 minus 26.30. So that is 2.20 grams. 2.20 divided by the molar mass of ethanol, which is H6O, will be 2 times carbon plus 6 times hydrogen plus 1 times oxygen. If we use the periodic table to find the molar masses, we'll see that it's 2 times 12.01 plus 6 times 1.01 plus 1 times 16.00. And the total for that is 46.08. Okay, this 46.08 is how many grams there are in 1 mole of ethanol. So it will be 46.08. And this gives us what these values are saying here is that 0.0477 moles of ethanol produced or released 27.17 kilojoules of energy. The question is, how many kilojoules of energy will be given out by 1 mole of ethanol. So we can do a ratio here. Five 69.60 kilojoules per mole. Okay, important to note here that this value is the is equivalent to the energy absorbed by the water, right? But remember, we said the energy that is released by the combustion will be equal and but opposite. So therefore, the heat of combustion, according to our result here, will be negative 569.60 kilojoules per mole.